Topic before us is circle theory. Circle theory. Circle. Sorry, it's a circle theory. Circle theory. When we talk of circle theory, we need to understand some things relating to circle. We need to understand some things relating to circle. What are the things that are related to circle? When you look at a circle, it's in form of an orange. A circle is in form of an orange. It is in form is circular. An orange is in circular shape. And when we talk of a circle, we have a center. We only have a center. Then we have what we call radius. This is our arm. Arm is radius. What is a radius? A radius is a line. A radius is a line drawn from center of a circle to the circumference, A radius is a line drawn from the center of a circle to the circumference. You can see as indicated in the diagram above here. From center to circumference is a radius. From center here to circumference here is a radius. From center here to circumference here is a radius. So any line drawn from center of a circle to any part of circumference is called radius. Beside that, we have another one called diameter. What is diameter? Diameter is a line drawn from a circumference of a circle, passing through the center to other part of circumference. Other part of circumference is called diameter. It is called diameter. Take for instance, we have a line from center here. We draw from circumference here to the center, passing through the center to another part of the circumference. So this line is called diameter. And if you look at it, D represents diameter. It means if you move from here to this place is a radius, and from here again to this place is a radius. Meaning that the diameter is equals to 2 radius. Diameter is equals to 2 radius. That is, this radius plus this radius will give us a diameter. So 2 radius will be equals to a diameter. Apart from that, we still have what we call chord in the circle. What is a chord? A chord is also a line drawn from circumference of a circle to another circumference, but this time around it will not pass through the center to another circumference. Once you draw a line from the circumference of a circle to another circumference, is called chord. What is a chord now? It means this is a circumference of a circle, but you draw it from the circumference here to this place. From circumference to this circumference, it is called a chord. So this line is a chord. This line is a chord. It did not pass through the center, but rather it passes through the circumference to the circumference and divided, and we can add it here, and divided the circle, into two segments, and it divided the circle into two segments. So that is what we call chord. A chord is a line drawn from the circumference of a circle to another circumference and dividing the circle into two segments. It divides the circle. You can see from the diagram that if you draw a chord here, this is a chord running from circumference to circumference. The upper one, this line is called chord, and we now have two segments, the upper one and the other one, called segment. So what is segment? This will not lead us to segment. What is segment? Segment is what? It is area. This is the what? Area. This is the area divided by a chord. Area divided by a chord. When we talk of segment, we said it's an area. Segment is an area divided by a chord. This is a chord now. When you look at the chord, this chord has divided the circle into two. We have the upper segment and the lower segment. Now, what we are saying here, in essence, is that the segment is what? With this one, the upper one is the minor segment, while the lower one is the larger segment. So when we say this is the area divided by a chord, the smaller chord, the smaller chord is what? Is a minor segment. It's minor segment, and the larger chord is major segment. The larger one, this is the area divided by a chord. The smaller chord is minor segment, and the larger chord is major segment. So these are the kind of information that we need to note under the circle theorem. This information is very important because from time to time we will be talking of radius, we will be talking of a diameter, we will be talking of a chord, of a segment. So once you can identify all these ones, it will be very easy for you to use it to calculate any question given to you relating to circle theorem. Apart from this, we are going to look into some theorems, because the theorems will be guiding us in our calculation. We prove one or two of the theorem, and we will now solve some examples of a circle theory. When we talk of circle theory, we are talking of the first theorem says the what? The first theorem says the area, the angle rather, the angle which an arc of a circle subtends at the center is twice that which it subtends at any part which is subtends at any point on the remaining part. The angle which an arc of a circle subtends at the center is twice that which it subtends at any point on the remaining part of the circumference. We are to show or prove that the angle which an arc of a circle subtends at the center is twice that which it subtends at any point on the remaining part of the circumference. There are some things that we are going to look into. We are to say given. What is our given? Our given is we are given a circle APB with center O. Circle APB with center O. We draw a circle. A circle must have a center O. We have A, this is our P, and this is our B. Their respective points on the circle. This is our point here. There is a point here. There is a point here. This is point B. This is point A. Then, what is next thing? Let us join it together. We have this one will come to A. This one will go to B. Alright? Now, this will join our point O. This will also join our point O. This is center O. Alright? If this is center O, we can join this passing through the center to a point what? Let's call it Q. To a point Q. Now, we are saying that if this angle represents x1, this angle will represent x2. This angle, let's represent with y1. This angle will represent y2. We have labeled our angles from the diagram we have. We are talking of A, P, B. That is the given angle. That's the given circle. Our given circle is a circle. The circle runs between A to B and back to A. Now, with what? Center O. Our center is 0. Okay? Now, what are we saying? We are saying that we want to prove that angle AOB is equals to 2 multiplied by angle APB. We want to prove that angle AOB, the angle we are referring to is this angle. When you say angle AOB? Because when you talk of angle AOB, two angles are on this point. AOB is this one. We still have another one called reflex of AOB. When you talk of reflex of angle AOB, it is this angle. When you move from here to this place, this is reflex. This angle is reflex of angle AOB. Whereas the real angle is angle AO to B. This is the real angle. But the reflex of it is the other one. What do I mean by reflex? You will see that this is now, this angle, the two angles now form angle at a point. Meaning that angle at a point is equals to what? 360. Angle at a point equals to 360. If you know the value of this angle, it means you can get the reflex of that angle. By subtracting the value of this angle from 360 will now give you the reflex of this angle. But in our proof, that is not what we are trying to say. But because it's also part of a circle theorem, we don't need to overlook it. And that is why I'm trying to emphasize on it, so that when we start working on it, we can come across a reflex of an angle. Then, hearing the reflex of an angle will not be strange to us again. That the reflex of an angle means it means that angle is operating at a point. And the sum of angle at a point is 360. Once you know the value of the other angle, subtract from 360 will now give you the reflex angle that you are talking about. Now, apart from that, we need to show, what are we showing now? That our construction, when you are to prove, you say we want to prove that AOB equals to 2 multiplied by APB. Our construction is based on our construction is join PO and produce to what? Point Q. That's our construction. We are to join. Initially, we said the circle given to us is a APB. By the time we sketch our diagram, we need to join P down to O and then produce to Q. That is our construction. It's our construction. It's not part of what was given to us, but to suit our proof, we need to construct it. It's very, very important. So we say join PO and produce to Q. Now, when you join PO and you produce to Q, what is the next thing? Our proof starts. We will now start our proof. What is our proof? You see that OA is what? O to A. OA is equals to what? OB is equals to OB. Side OA equals to line OB. Line OA equals to line OB. What is the reason? The reason is that they are all radii. They are radii. Radii of the circle. What do you mean by radii? Radii is plural and radius is what? Singular. This is, I said earlier on that any line drawn from center of a circle to the circumference is what? Is a radius. You can see that this line OA is from the center to the circumference. If you look at OB is also a radius drawn from center to the circumference. Likewise, if you look at it from center again to this place, it's also a radius, not from Q. There's a difference between look at this one and this line. We have PO. PO is not the same thing as PQ. So what I'm saying here in essence is that any line drawn from the center of a circle to the circumference is what? Is a radius. Telling us this morning that OP is a radius. OP is a radius. So OA is equals to OP. Now we are saying that that is the reason why we say that. Now angle OAP. What is angle OAP? Angle OAP. Let's look at it. Angle OAP. OAP will be equals to what? Angle OAP. This is OAP. Before then, you will get it clearer that this is a triangle. APO is a triangle. A moving to P, coming to O, coming back to A is a triangle. What type of triangle is this? If you look at it very well, APO, what type of triangle? The type of triangle we have here is isosceles triangle, because this is a radius, this is a radius, and this is a line. We said in an isosceles triangle, two sides must be equal. Now, if two sides are equal, it means the two base angles must also be equal. So what are the base angles of this isosceles triangle now? X1 and X2. They are the base angle of isosceles triangle. So what we are now saying is that angle OAP, which is this angle, will be equal to what? It will be equal to OPA. It will be equal to angle OPA. It will be equal to angle OPA. We did that x1 equals to x2. The base angles of what? Of isosceles. Base angle of isosceles. Base angle of isosceles. X1 equals to x2 is the base angle of isosceles. That is the first proof. The second proof is that we have to say that angle AOQ. What is angle AOQ? Angle A, this is a AOQ. This angle, what will be the value of this angle now? We want to find this angle. AOQ. AOQ. Angle AOQ will be equal to angle OAP. OAP plus what? Plus angle OPA. Angle AOQ, this angle will be equal to angle OAP plus angle OPA. What we are saying now is that angle AOQ will be equal to OAP is x1 and OPA is plus x2. Okay, now that is our AOQ. But we need to understand something here. That x1, we said this here earlier, that x1 is equal to x2. We need to substitute 1 here. We need to substitute 1 here. Meaning that here we have to say that since s1 is equal to s2, we can now say that our angle AOQ equals to what? Will be equals to x1, it will be equals to x2 plus x2. Because anywhere we see x1, instead of x1, we change it to x2. This is x2 plus x2. And this will now give us 2x2. 2x2. Alright? Angle AOQ is equals to, therefore, we say that angle AOQ equals to 2 multiplied by angle OPA. 2 multiplied by angle OPA. 2 AOQ equals to 2 multiplied by angle OPA. And that is 2 multiplied by OPA. Where is the OPA? OPA. PA. So what we are saying now is that if this angle is 30 degree, I want to get AOQ. It means AOQ will be what? 2 multiplied by 30, and that's 60 degrees. That means this angle will be 60 degrees. If this one is 45 degree, if you want to get this angle, multiply this 45 degree by 2 will give us this one as 90 degree. It means this angle will be 90 degree. If this place is 80 degree, we want to get this one, multiply this one by 2 will give us 160 degree. And that is what we are talking about here. And it is also reversible. If this place is 80 degree, this is 80 degree, 80 degree divided by 2 will give us 40 degree. It means this place will be 40 degree. So that is what we are trying to explain here. So similarly, we say that AOQ, that is the angle AOQ. That is, if you want to talk of this one now. Similarly now we talk of AOQ. Similarly now, this one must be BOQ. Similarly, this one will be BOQ. That is BOQ will be equals to what? Will also be equals to 2y2. Because this one is talking in terms of y. We have to follow the same procedure. From here to here is also a radius. This is also a radius. Okay? Then it means this triangle is also an isosceles triangle. Being an isosceles triangle, it means this y1 must be equals to y2. Like you have in y1, like you have in s1 equals to s2. This will also be y1 equals to y2. And that's the reason is that the y1 and y2 form the base angle of the isosceles triangle here. Now, the next thing is we are to say that we want to find, we are leading to a theorem that BOQ equals to 2YQ. When we have BOQ, this is AOQ and this is BOQ, then we can say that angle what? Angle AOB. Angle AOB, we are talking of this angle now. Angle AOB, our angle AOB will be what? AOB will be AOQ. Angle AOQ plus angle BOQ. Angle AOQ plus angle BOQ. Now, what are we saying? We say that angle AOQ equals to 2x2 plus 2y2. 2x2 plus 2y2. Angle AOB equals to 2 into bracket x2 plus y2. 2 into bracket x2 plus y2. That is, if you know the value of this angle x2, y2, the angle here, multiplied by 2 will give us the value of AOB. Multiplied by the value of 2 will give us AOB. And that is the theorem that we are asked to prove. That is, angle at center is equal to 2 multiplied by the 1 at the circumference. Angle at center, this angle, multiplied by angle at center is equal to 2 multiplied by the 1 we have at the circumference here, give us this angle. What are we saying? If this angle at circumference is 60, the one at center will be what? 60 multiplied by 2, give us 120. And if you are giving this one as 120, you have to find the angle at circumference. It means what? 120 divided by 2 will give us 60. This is the angle at the circumference. And that is the answer to our problem. That is the answer to our problem. That's of the first theorem, which we will need in our calculation. 2. We need to prove another theorem. The second theorem says the angle in a semicircle is a what? A right angle. The angle in a semicircle is a right angle. The angle in a semicircle is a right angle. Given the angle in a semicircle is a right angle, what is our given here? We are given a circle APB again, APB with center O, We are given a circle APB with center O. Let us draw the diagram now. This is another theorem. Let us draw it now. Now we have this. This is center. Okay. Now we have AB. Then we have this. Come down like this. So what we are saying now is APB equals to this. This is a center O. This is center O. So we are saying that the angle in a semicircle, this is a semicircle now, because AB is a diameter, it has divided the circle into two. A diameter is a line run from circumference of the circle, pass through the center to the other part, to another circumference. It can be divided the circle into two equal parts. A diameter divides a circle into two equal parts. Now we want to say that we want to prove that AOB is a straight line. We go to our proof now. Our proof now is that AOB is what? Is a straight line. AOB is a straight line. Hence angle AOB will be 180 degree. Angle AOB will be 180 degree. But angle AOB, that is this angle now, when we talk of this angle AOB, this angle, according to our first proof, we said that it is what? Is angle at the center. Then it was equal to what? 2 multiplied by the one at the circumference. The one at the circumference now will be APB, because this angle at circumference, this one is angle at circumference. So it means AOB, if you want to find it according to our first proof, is equal to 2 multiplied by APB. Now, that's the reason is that angle at center equals to 2 multiplied by the one at circumference. Therefore, our APB will be equals to what? It will be equals to, these two will come back here. It will be equals to half of AOB. It will be equals to half of AOB. Now, our APB, we said it earlier on that AOB is a straight line, which was 180. So if you say half AOB now to be 180 divided by 2, which is equals to 90 degree. It means APB, once you have a straight line or a diameter, then that diameter forms a triangle. It means at the circumference, the angle there must be equals to 90 degree. The angle there must be equals to 90 degree. That is the another proof that you need to understand under the circle theorem. Another proof that you need to understand under the circle theorem. We still have another one called cyclic quadrilateral. What we say cyclic quadrilateral? We have cyclic quadrilateral A, B, C, D. How? This one join here, this one join here, this one join here, this one join here. So we said this is a center. There should be a center. If you join this one to this place, this is center, and this one. Alright. So what we are saying here, this is cyclic quadrilateral. Cyclic quadrilateral. Cyclic quadrilateral. This is cyclic quadrilateral. When we say cyclic quadrilateral, we are saying that BAD, angle BAD equals to angle BCD. It's not, they are not equals to. Angle BAD, okay, plus BCD must be equals to 180. In a cyclic quadrilateral, the opposite angles are supplementary. What you are saying that in a cyclic quadrilateral, the opposite angles are supplementary. The opposite angle are supplementary. In the cyclic quadrilateral, the opposite angles are supplementary. So what do we mean by supplementary? When we say two angles are supplementary, it means when you add the two angles together, it must give you 180. When you add the two angles together, it must give you 180. Then they are supplementary. Then another one, if you add two angles together, when you add two angles together and it gives you 90, that one is what? Complementary. When you add two angles together and you get 90, that one is complementary. When you add two angles together and you get 180, that one is supplementary. So supplementary and complementary are not the same. Complementary means two angles must be equals to 90. Supplementary means two angles must be equals to 180. So in the cyclic quadrilateral, when you talk of the cyclic quadrilaterals, the two opposite angles, when you add it together, it must give you 180. Likewise, this angle, when you add these angles and this one together, it must also give you 180 because it's also angles in the cyclic quadrilateral. So that's another theorem that you need to note. Now, apart from that, there's another one, angles in the segment. Angle in the segment, this is center. Perhaps you have something like this is center O. We have something like this. We have something like this. This come down. Okay. We have another one. Maybe you have another one this way. This is another one this way. This is a x1. This is a x2. Then we say that the angles formed at the segment are always equal. They are always equal. Angles at the segment of a circle are always equal. It means this x1 must be equal to x2. If x1 is 75 degrees, x2 must also be 75 degrees. If x2 is 35 degrees, x1 must also be 35 degrees. So in other words, any angle formed on the segment of a circle are always equal. This is another theorem of a circle theorem. This is also theorem of a circle theorem. So knowing all these theorems now, you can now start using it to calculate one problem or the other. We can use it to solve some problems in mathematics. So let's look at our problem, then we'll now solve it through Now let's look at this question. This question says this is y